Okay, hello, how's it going? In this series, the next thing I want to do is I want to look at skeletal animation, but before I do that, I need to load in models which support skeletal animation, one of which is the glTF format. glTF stands for GL transmission format, and it's actually designed for massive scenes. For contrast, what I've done here is I've basically exported the Blender default cube. If we open that in OBJ form, it's very, very readable. And this is really best if it's just dealing with one single object. See, we have vertices, textures, normals, faces, and so on. Now, if we look at this in glTF, it's in JSON, and there's a whole bunch of extra metadata. This is designed for a whole scene which could have several different objects, and every object in the scene is represented with a node, and it's a lot more semantic, which is good if we have a system to read this, and otherwise it is a nightmare. Like if I'm just writing my own reader, honestly, I'd prefer this, but glTF is a more expressive format. Yeah, so just to look through here, we have a scene, and then a scene has a bunch of nodes, and a node could have other nodes, like other children that depend on it. We have materials, and if there were textures, then we could also embed the textures into this, I believe. We'll see. And yeah, attributes. And then we have these accesses, which I will be completely honest, don't 100% understand this format just yet, but I believe the accesses have buffer views which are essentially attributes, I believe. And then we have this this buffer, and this buffer is actually embedded directly in the file, so it's basically not showing up very well because this is the raw binary data of some stuff. So as I was alluding to, it's probably not the most fun exercise to write a loader, and for that reason several loaders exist, including this tiny glTF model. In the same vein as the tiny OBJ loader, this is a header only. I just pop back here. See, this one here is using GL 2.0. So use that one. I think it's actually the same thing. But yeah, so the first section in this video is going to be installing the tiny glTF loader to our project. The second part will be loading models, and the third part will be drawing models. And this will just be static models. We won't have skeletal animation just yet. There's enough to unpack as it is. So if we go down, here we go. It says we need to copy STB image, STB image write, JSON, and tiny glF. So I'll grab all of those. Actually, you know what? I'll just download the whole thing. Now, before I bring that over, that's fine. Before I bring that over, I'll just note, hey, we've got STB image already, so we can actually get rid of that because I just want to declare that at one point, and then similarly in the view, I've also included it, so we'll just get rid of that. But yeah, let's get into it. Okay, so again, we'll pop in here and we want, what was it? See if I can remember. It was the STB image, image write, tiny glTF, and JSON. Okay, grab those. And I'll make a folder in dependencies called tiny glTF, because these are all the dependencies which it uses. And great, that's looking good. So then I'll open up the project. Make the text a bit bigger. And what do I want to do? Well, of course, we're going to have to remove that and then view. Okay, that's looking good. So what I'm actually going to do is I'm actually going to make a file called config.cpp, and that will actually implement all of those things, because I was having trouble before where I was loading, including image, but then I had to declare it in multiple spots or something. It was a bit weird. So I'll create that. I know this is very exciting. I'm just trying to remember what I did. So that is all fine. I'm going to shake things up a little bit. So I'm going to grab that image structure and I'm going to declare that in the image header. So if I go over to image.h, I want to declare that here. Okay, and then in config, oh, maybe not there, image.cpp, there we go. Okay, so I don't want to include this. So I'll go down to my config, and I define this, so I'm saying, yep, this is the, at this translation unit, this is the point where I want to include, where I want to actually implement STB image, and then I go ahead and include it. Okay, so that should be fine. My system should now have glTF, STB image, again, should be working just fine. We'll just run into issues over here because now this, now this will be complaining. It'll be saying, hey, I don't know what that is. But guess what? Because we've implemented it, we can now simply include it wherever we want. So we go, include that. That is fine. Then we go over, check that. Yep, those errors are gone. Awesome. Okay, so back to it. That text said we also needed to define a few other flags, and that was these ones here. And I'm also going to, of course, include that library. Now the test is, will this throw an error? Let's find out. And luckily, it does not. Okay, fair enough. What's this on the right? GeForce Experience. Geez, you update your drivers, you think it's going to make things better. You just get all these overlays. Okay, cool. So that is installing tinyglf into the project. So the next part of this is loading in a model. And again, for this part, I'm really basically taking a lot of inspiration from the examples, specifically this basic example here, which is fine. That's what examples are for. So we can pop over to View and make a new file. And I'm going to call this, we have obj mesh, so let's go glTF mesh.h. Okay, so we'll just include everything that we need to. Okay, that's looking good. Then we'll make a class for our glTF mesh. All right, so what data do we need? Well, we're going to store a tiny GL, I hate saying that. We're going to store a model And that is sort of a semantic data structure which holds a whole bunch of information that we'll use to render things, including the underlying data and buffers and things. Then, again, just working off the example, we need a vertex attribute object, a VAO, and we need potentially a number of element buffer objects. If we had one object, we'd just have one EBO. But if we had multiple objects, like multiple nodes in the scene, we would need an element buffer object for each of those individual objects. So let's wrap those together. And another thing is, originally in the OBJ model, we had a pre-transform matrix. Now, I haven't really found a way to incorporate that just yet, but I am going to approximate it by storing a scale factor in a float. Basically, because the model that I'm loading is too big for the scene, so I'm just going to store that. So what are we going to do? Well, we're going to construct the class, and I'm going to take in a file name and the scale factor that I want to associate with that model. Then I'm going to want to, of course, destroy the model. But I also want to bind the model. And this binding the model is a high-level function. It's not going to do too much. It's basically going to make the VAO, and then it's going to jump into the components of the model and bind their individual bits. So go. Just to make it a little neater, I'll make some of these other little sub-functions private. Technically, bind model should be private as well, but because I'm thinking of it as a high-level function, I'll include it in the public section. Why not? And one of those is the model nodes. Okay, so what this function will do is it will take one of the nodes from the scene, and if that node has any meshes associated with it, like if it's an external node of some sort, then it will look into that and register one of those element buffer objects with the set of element buffer objects. And it will also recursively look at that node and see if that node has any children and inspect those as well. And finally, I'm going to have the mesh binding function. And that is the function that will actually look at the associated mesh for a node. Okay, so let's make another item. We'll make the source file for this, glTF mesh.cpp. And we'll get into it. Okay, so what will we do? Well, let's set a few things up. Okay, so we grab a context of the library in order to load things, and these strings, well, it's pretty self-explanatory what they'll be used for. They'll be holding various messages. So we take the loader and tell it to load this ASCII from file, and we take the model that we want to populate, that is our model there, and then the error that we want to fill in, the warning string that we want to fill in, and then the file name. So the file name is up here, and that's all we need. Then I want to check whether we got any errors or warnings. Or if we got any errors. Okay, fair enough. Then there's a number of other things we can do. One of them pretty straightforward. Simply store the scale factor. That was... Why can I not type? The scale factor that was requested, and then we need to bind the model, and that will return that the pair of the VAO and all the EBOs. So we'll store that there. Cool. Now we have this destroy static mesh, but I'm actually not going to look at that yet. I'll look at the model first, and that should give more of an idea of how this works. And that's it. It's done. Just kidding. Okay, so we need to actually populate this vertex attribute object. So we'll go generate. Okay, good. And then the next thing we need to do is create an element buffer object for every node in the scene. So we need to go ahead, look through all the nodes in the scene. Okay, so we're just grabbing the scene out of the model, and then we'll loop through that. Okay, so we're just doing a basic error check here to check that the scene is valid, or the the given node is valid, and provided it's valid, I mean, then we'll bind that node. Okay, so now that we've done that, we can sort of unbind the VAO. We're fine with that because this binding model nodes will associate each of the EBOs that are created to that VAO, and then afterwards it makes sense not to have it bound. Now, I typically don't do this, I typically don't worry about it, but for whatever reason it was throwing an error if I didn't put it in, so let's keep it there. Now, there is some more work we need to do, but first I'm going to jump into the rest of the functions and get back to that. So again, what this is doing is it's inspecting a given node and checking it basically. Now, the reason that I'm running this conditional statement again, even though I asserted it above, is that this is a recursive function. So it may throw into another node. We still want to check whether that is valid. So anyway, if that is valid, then we want to bind its mesh. We want to bind it into the EBOs set. And we'll grab from the models set of meshes that node's mesh. Okay. So the next thing we want to do is we want to look through all the nodes that this node has. And bind those children. Okay, great. Now on to binding the mesh, and this is the more involved function. Okay, so things are starting to get a little bit more esoteric. Now, what this is doing is a buffer view is a high-level structure for viewing a buffer, if that even makes sense, for interacting with a buffer. And the buffer view has something called a target, which is the type of buffer that it's referring to. If it's a VBO, EBO, something, there are other types, storage buffer, for instance. And if we have a target of 0, that's an invalid buffer. That's not really targeting anything. So once we've got the buffer view and check that it's valid, we then grab a reference to the underlying buffer that it's referring to. So the, the actual element buffer object, for instance, or the actual vertex buffer. And then we can go ahead and generate the EBO for that. Okay, so we have generated an EBO, and then we have placed it into the set. And then we want to bind that EBO to start working with it, for instance, to send the data in. Okay, so first thing we have is the target that we're going to bind to, and I don't know what the target is, but buffer view does. And then what do we have? The size, number of bytes. Again, buffer view has that. There's a byte length struct. Then a pointer to the data. So what we can do is we can go... Again, I am actually taking this from the example. Okay, so what this is doing is we're saying, get the start pointer, start location of the buffer, and then add on the buffer's offset, and that will be the location of the data. Then the next one is usage, and we'll just go static draw mode. Okay, so that's basically set up the data. Next thing we want to do is look through the primitives for the mesh. Okay, great. So we have these structures here. And again, this is where it gets foggy, so it's okay if you just want to copy paste the code, that's fine. Where were we? So again, what we're really getting to, at this stage here, we have the data loaded into the element buffer object. That is perfectly fine. It's this stage here where we create the attribute pointers to access the attributes. Okay, so just double check. So if I go to my shader and vertex, I believe, yep, then 0 is position, 1 is texture coordinate, 2 is normal. So set this to 0 for position. Then I believe it's texture coordinate 0 is the flag internally for texture coordinates, and then normal is attribute 2. Okay, so basically, I know this is foggy. This isn't a great video. You can just copy paste this code, totally fine. But I just felt that it would make a little more sense to step through it. Anyway, so what this is doing is sort of looking through the attributes of the primitive, and then checking which sort of attribute it's describing. And then, provided that we've got a valid attribute, so say something bigger than 0, then we can write in that that attribute. So we'll go enable, and then create the attribute pointer. So again, just so this makes sense. So attribute is the index, attribute 0, 1, or 2. Size is the number of components. Is it a vector 2, vector 3, and so on? And that is found up above. And then the next one here is type. And to get the type, we look at that accessor. What is it? Component type is the one, right? Whether it's a float, an integer, or so on. Normalized, now most of the time this will just be false, but let's check that. Okay, that's good. So yep, got that there. All right, and then the stride. Now we calculated the byte stride above, so we'll use that. And then the pointer, which is actually, it's the offset. I know it says pointer. By the way, How descriptive is a pointer called pointer? Oh, anyway, okay, so what we want to do is we want to take this is a bit funky. This is a bit very funky because access a byte offset should really just be the thing, but we want to get that as a byte pointer. Alrighty, so that is that part done. It's quite a mouthful there. Look, I've said this so many times. This is a bit in the weeds, and I'm not explaining it very well. I'm aware of that. But the point is we're making progress. We've got that. We can use that for loading our static models. Now, the next thing we want to do is we want to look through that set of EBOs, because I know I said EBOs, but we might be putting in things that aren't EBOs. Like we go down below. If we go down below, we are binding an array buffer. So I just want to check through and delete anything that isn't an EBO. Okay, cool. So what we're doing here is we're saying, hey, let's iterate through the set of EBOs, grab the first element, which is, of course, the integer location associated to that EBO within the within all of the buffer views, and then say, hey, is that targeting an element buffer or not? And if it isn't, then delete it, erase it. Otherwise, just step forwards. And that's it. So that actually gives us an idea of how we can delete everything. So we can now look at the destructor. Alrighty, so we're deleting the first element there of that pair, which is the VAO, and then we want to loop through. And everywhere we see EBOs, that's really the second element. Yeah, so there we have it, unconditionally just deleting everything. So in theory, that should now be working. In practice, who knows? Let's see what we can do for now. So we'll just head to the engine and import everything. And say, okay, well, I know that I've got, where is it? Where is it? Here we go. We've got an object mesh cube model. Let's redo that. Let's make a glTF static mesh cube model 2. That's fine. Then head over to the engine in the create models. There we go. Over here, we'll just go cube model 2. Then for the file name, we'll go models. And for the scale, well, it looks like here we have a scale of 0.4. So let's go with that. Let's go 0.4. Okay. Right. So then in the destructure. We'll just destroy that as well. Okay, now, fingers crossed. I'm not really doing anything, but let's just check what this is doing. It's probably some silly error. What do we have? Oh, that's not a silly error, that's an annoying error. Unresolved external symbol. Oh, how did I miss that? Jeez. Okay. Hey. There we go. Let's. Forgot to define the tiny glF implementation. glTF. How did I miss that? Oh, because I pasted that. Oh, jeez. Oh, sometimes I wonder. Okay, let's see what have we got here. Okay, I guess maybe tiny glTF already imports STB image. Right. Okay, now this is the error I was actually expecting to get before. What does it say here? sprintf is unsafe. Consider using sprintf-s instead. No problem. So this occurs in stb image write.h line 742. So we just open up the dependencies. stb image write 742. Okay. Good. So see here it says we're using this sprintf-s, and it says we should use the safe version, and that safe version is triggered if this has been defined. So no problem. Let's just go back here and define this as well. There we have it. It's working so far. And that's just loading the model. So we don't actually know if these models have loaded correctly because I'm using the OBJ models at the moment. But yeah, that was stage 2. That was a lot of fun. Okay, so the final thing we want to do is actually draw the mesh. We'll just go to the header and add the functions. Okay, so we have this prepare for drawing function, and that will basically arm the VAO. And then this draw is the high level function, which will then step into the individual components and draw those. Prepare for drawing is going to return a float because I want to return the scale factor. So when I use this model, I say, hey, I want to draw you. And the model says, okay, yep, you want to draw me, I'm ready to draw, here's my scale factor, just so you know. And then when I calculate the model matrix for each model, I can incorporate that scale factor. Okay, so next thing I want to do is I want to draw a node. And that will recursively step through and draw the node and its children. And then I want to draw the mesh. Okay, good. So let's go ahead and define these functions. Okay, so prepare for drawing is quite straightforward. All we'll do is bind the VAO. And then return our scale factor. Okay, now for the draw function, we'll grab the scene and go ahead and draw each of its nodes. Okay, good. Then we have draw model nodes, where we will recursively step through, draw any associated mesh, and inspect child nodes. There we go. Excellent. So we've got all of that. Then finally we have the draw mesh function, which will go through and draw all of the primitives in the mesh. Okay, so there we have it. Pretty similar to some of the other stuff we were doing. So yeah, this draws the underlying EBOs. Okay, so in theory, this should now be working. What we can do is we can go to our engine, to the draw, oh, that's all fine, okay, to the draw function, and then what have we got down here? So see here, we are binding the cube model. Okay, no worries. Let's take cube model 2 and prepare it for drawing. And again, that will return a scale factor. And then we can incorporate that in the, where are we? Yeah, the model matrix. So we can go GLM scale. So we want to scale this model transform, and we want to scale it by okay, cool. And then here where we do the draw elements, we can go simply draw it. And we'll do something very similar. Yeah, so fingers crossed this now should be working. Those cubes might not look exactly the same. It's not a perfect system, but oh, and they're not there at all. Ooh, that's very interesting. Okay, I'm not sure if this is the issue. Didn't fix it, but it is an issue. Over here, attribute, yeah, -1 isn't so great. We only want to, okay, so we don't want to be bigger than 0 because that's excluding 0, so just bigger than or equal. But again, that's not the issue. So I know it's not very satisfying, but in the end I took my example code that I adapted from the example and worked on, pasted it over, and it worked. I think It's probably some dumb bug that I made when I wrote this out, but I think the issue could be, where are we? Here, using oh, it is an unsigned int. Oh, anyway, I don't know what the issue was, but it's working now. So I mean, I had been through that line by line. It looked the same, but it's, yeah, probably some dumb error that I made. But here we have it. The cubes look not quite the same, but I mean, their position feels like it's a little bit off. But anyway, we're using glTF model formats for static models. And this could be, you know, any sort of model. And we'd load it. In the next video in this series, we're going to have a look at skeletal animation. All right. Look, I know this video is a bit wafty, but it felt like a significant modification to the code base, so I wanted to document it so that I wasn't just coming in and saying, here's the thing, I did it. But yeah, anyway, hopefully that was at least entertaining, and I'll, see you again soon. All right, bye.